Hello, I am Zhang Yuanhao, and I am an undergraduate student from Hong Kong University of Science and Technology. Today, we are going to talk about a paper exploring the effects of self-mockery to improve task-oriented chatbots' social intelligence. Task-oriented chatbots have undergone fast development in recent years and are applied to numerous domains, including but not limited to the domain of education, healthcare, and customer service. However, breakdowns and avoidance frequently happen during their interactions with human users, and such shortcomings could lead to user dissatisfaction and frustration, triggering the abusive behaviors or even the abandonment of the conversation. So to mitigate these challenges, SIGCHI researchers have tried to apply humor to the chatbots to improve their social intelligence. So what is the social intelligence of the chatbots? It refers to the ability of an intelligent agent to respond to the social cues, accept difference, manage conflicts, be empathic, and demonstrate caring behaviors during the conversation with users. It can be further ascribed to the following 6 features, which are damage control, thoroughness, manners, moral agency, emotional intelligence, and personalization. The explanation of these 6 features has already been shown here. Although the current research have tried to apply the humor to the chatbots to improve their social intelligence, there still exists some gap. Firstly, previous work only focused on the limited features of the social intelligence, and few work studied how to improve multiple features at the same time. Secondly, few works in the HSI domain focused on investigating the benefit of applying the self-oriented humor, which is the self-mockery, to the chatbot to improve its social intelligence. Thirdly, most of work related to the humor only focuses on applying humor in a specific scenario, like when ice-breaking or when the chatbot fails. Therefore, our research aim is to apply self-mockery to the task-oriented chatbots to exhibit overall social intelligence across multiple scenarios around the task and alleviate the challenges they face in more general settings. And we mainly focus on exploring the following research questions. We first explore how to design self-mockery language for the chatbots and how does it affect the user's overall satisfaction. And secondly, we explore how the users perceive the overall effects of self-mockery design and its helpfulness in the different interaction stages towards different aspects of the social intelligence of chatbots. And lastly, how do the users' individual factors influence their perception of the social intelligence? So now let's come to the self-mockery language design. For the self-mockery language generation, retrieval-based method and generation-based method are the 2 most common methods used by the chatbots. However, due to the limitation of human resources and the database, we decided to abandon the retrieval-based method and apply the generation-based method, which is mainly to compile new sentences to respond to the user input. To effectively apply this method, we propose to create the design templates based on the series of self-mockery in the human-human interaction. Our assumption is that mocking on the perceived difference between agents and humans could be a practical way to achieve the effects of the self-mockery for the chatbots. Based on this assumption, we drafted a systematic way of generating self-mockery sentences for chatbots, which was to construct the 4 components first, and then fill them into the design templates for different scenarios. So the 4 components in our design template is listed as follows: A, task-related details; B, human cognitive systems; C, issues in chatbot components; and D, human or chatbot solutions. So this is the self-mockery language generation pipeline. Simply speaking, it is just firstly to select the specific features and corresponding cognitive systems to mock and generate relative components from A to D, and then it adapts and fills these phrases to the predefined templates for different scenarios. And lastly, it rephrases the generated sentences to make them more consistent. We implement our chatbots with Rasa, a leading conversational AI platform. And we simulated an online shopping context where the chatbot served as a shopping guide, a common approach for many online shopping platforms, and also a major channel of the chatbot usage. Our chatbot's user interface are shown at the right side. Let's come to the part of the evaluation. To answer RQ1 and RQ2, we conducted a set of hypothesis testing with the following three hypotheses. You can see that H1 and H2 mainly address the aspect of user perceptions towards the self-mockery chatbots, while H3 mainly address the influence of the self-mockery design towards the different features of chatbot social intelligence. To further address RQ2, we compared the perceived helpfulness of adapting self-mockery for the chatbots in different scenarios towards the individual features of social intelligence. And for RQ3, we conducted regression analysis to understand the impact of individual factors on the perceptions towards the effectiveness of incorporating self-mockery on the chatbot's social intelligence. What needs to be mentioned here is that all of these are measured in the standard 7-point Likert scale. Here show the results of the evaluation. We can firstly see that the manipulation check for the chatbot with self-mockery design shows that the manipulation is effective. And from the RQ1, we can see that the participants consider the self-mockery chatbots as the funnier one, and they are more satisfied with them, and they are more inclined to use them again. And as for the language appropriateness, we did not perceive any significant difference between the baseline chatbot and the self-mockery chatbot. As for the RQ2, we can see that only the aspects of damage control and emotional intelligence, we can perceive significant difference. Here shows the results of the perceived helpfulness in different scenarios. And we can see that this result showed no significant difference in the rating of self-mockery design in 3 scenarios, in the aspect of soreness and manners. And in the aspect of the damage control and emotional intelligence, there exists weak significance. And as for the moral agency, there exists strong significance. As for the effect of the user's individual factors on perceived helpfulness, the result shows that the participants with higher social orientation were more likely to perceive self-mockery language as helpful in regard to all features of social intelligence under all scenarios. And we can see that most of the p-values here shows the significance. And apart from the factor of social orientation toward the chatbots, we further discussed the other 2 individual factors, which are service orientation and experience with chatbots. And we did not perceive the significant effects of these 2 individual factors. And we acknowledge that our work has several limitations. Firstly, we only tested the self-mockery chatbot with relatively younger user groups. The previous study indicates that different from younger users, older users focus more on the chatbot's efficiency and effectiveness instead of their social skills. Secondly, although we proposed a systematic pipeline to generate self-mockery sentences for chatbots, this process is not fully automated. It requires selecting the key components to compile the self-mockery and tailoring the sentence after filling the templates. Finally, the participants only interacted with the chatbots as one-time customers, as this is how the majority of chatbots are developed in the real-world applications. However, there is a trend that more and more chatbots start to have memories and interact with people over time. So that should conclude all my presentations. Thanks for watching, and please check out our paper.